Hey everyone, today we are going to talk about the fast gradient sign method, also known as FGSM attack. FGSM is one of the earliest cyber attacks on AI models. It is a mathematical process whereby we add noise to an input image. This noise, while it doesn't detract from humans classifying the image, it often confuses AI models. This can have a huge business impact if you have a business such as a self-driving car that relies on image classification. In this video, we'll show you how to code one of these attacks. Let's begin by putting some header information at the beginning of the file. That way, when we come back, us or someone else will know what we're doing. This adds a little bit of time to the video. This code is in our GitHub, so you can just go and look there if you don't feel like following along. And here's a reference from TensorFlow, that this is where a lot of this code is from. Next, we're going to import the different libraries that we need. You can see right here we get code suggestions. That's from an AI agent that Google's Colab has started doing in it. Sometimes it can speed up the process. Sometimes it can also give wrong suggestions, make it a little bit longer. It's up to you what you prefer. All right, next we're going to put in the data. We're using a different type of model for this video, not the MNIST model that we've used in different videos prior. You can see it's a pre-trained model. You can see I left off a library. That's one of those errors I was talking about. The AI suggested code sometimes gives. All right, let's define our functions now. We're going to have a function here to pre-process the image. Again, I add extra information at each function. That way, myself or anybody else that uses our code later knows what's going on. This, again, does add some time to the videos, but I think it's useful. If you don't want to use it, again, you can go to our GitHub account. See, that was one of the times that the AI suggested code was actually useful. This function is useful for getting the probability that a certain image is a certain class. This will be useful in our demonstration later. Next, this is where we're going to have the function that does some of the magic of the attack, create the adversarial example. Remember from our intro, we are taking noise and adding it to an image, where to the human eye, it still looks like the original image, or we can tell what it is. However, it's distorted enough that it fools the image classifier. Okay, here you can say we're using TF gradient tape. You'll see this a lot of times in different AI stuff. This is doing some of the math that we were talking about. All right, next we have our main. You can see we're getting an image of a yellow labradoodle. Yellow lab. And that's the base case. We're going to try to see if an image is in a lab, and then we're going to add the noise to the images, and then we'll see how the confidence and suggested class changes for the image classifier on images that have the fast gradient sign method attached to the image. We're doing one-hot encoding. That's a way to simplify the process a little bit. We're going to show the perturbations, aka the noise that we're adding to the image from the fast gradient sign method. We'll find different epsilons. This is how much noise we're going to give to an image. In the real life, if you add too much, it's going to be super obvious. Maybe not to the image classifier, but perhaps a team that comes in for quality control. If you're a malicious actor, you would like to not be detected. We're going to do this attack with those different epsilons like we said. That way you can see the difference as this attack is more or less noisy. If you look, I forgot to define our display images. Need to go back and put that on there. It's just a function that is automating some of the process. So every time we try to show the image, because we're doing this for a couple of different images, we don't have to write it all over again. So we just need to type that out real quick. All right, now let's fix everything and then run our code again. A couple more errors. Get another typo. Let's try this again. Couple more typos. Comma and a period can be the end. There you go. You can see there's the noise we're adding, and there's a couple different ones. There's the original image of the lab, and then at different epsilons, you can see that that was predicted as a different dog, and then that is predicted as a different dog at a different confidence. You can see as we change the epsilon, the image gets more and more noisy, and as a result, there are different predictions of what the image is, and then a difference of confidence scores. This seems like an academic example. However, this is something you need to be aware of for your image classification that you have in your projects. This is a way a malicious actor, or honestly just poor data, can get around your model, and you want to make sure that your model is protected against that. We'll talk about different ways to protect against this in later videos. Hopefully you enjoyed this video. Give us a like and subscribe, and check out our GitHub. Thanks.